Okay, so we'll go ahead and get started. On the left-hand side here, you can see the content that we'll be going over because it is what your final is also over. Okay? For some reason, we're getting better with those glares, but I think this will work just fine. Okay, we started the semester with Bohr models and electron configurations. Then it says dot diagrams and naming compounds. Then we went on to chemical reactions, which would include both balancing and classifying reactions. And then finally, we had wrapped up organic compounds. And a little side note here. On the final, there's some general questions from Chapter 23 that deals with organic compounds, and then also some potential vocabulary from Chapter 23. And keep in mind, even though you're in here for 2 days, your final will be on Thursday. Okay? I think we'll just do it, or no. Trying to recall when the afternoon session is, if theirs is on Thursday. I think theirs might be on Thursday. But you'll have it the same day as the afternoon session. Okay, so whether that's Thursday or Friday, we can discuss that next week. Okay, so when you look at that list, what is it that you would like to go over in any particular order, or else I will just go through random problems? Asking for input. And your input is what? So I'm going to say, I hope it's not a lot of work just to pick a topic out and actually discuss that. Okay, so naming compounds. If you don't have your periodic table out, you may want to do that because you would need that. So while you're doing that, I'm going to go ahead and warm this up and then we'll get started. Okay, so this would also include writing out chemical formulas and adding together atomic masses when we're talking about naming compounds. Okay, so go ahead and get started. So we'll start with just these three to begin with, okay? So we either see the compound provided, or excuse me, the formula provided, and then you write out the name of the compound. Here, we actually have the compound written out, and then we write the formula. Okay, so moving forward, K is the symbol for what? Okay, so that is potassium. Okay, and then NO3 is nitrate. Okay, and when it's written out like this, the compound's already balanced because the charges have to add up to what? 0. Yeah, because this is -1, that's +1. That will now add up to 0. So then the last thing we would do is add together these atomic masses. Okay, oxygen has a mass of, okay, all right. We'll have to take you out of lost and put you into found. So be just a moment. All right. So then, what is the atomic mass of oxygen?
16.
Okay. So how many oxygen atoms do we have?
3.
Okay. So how do we figure out all of the oxygen atoms then?
16 times.
16 times 3 would give you,
48.
so we got 48 for oxygens. Nitrogen is what? Go to the round to the nearest hundredth. Okay, so 14.01. And notice we only have one according to our formula. And then potassium is what?
39.01.
0.01. Okay, so we add those together. Okay, I think that's right. Let's see here, 12 and 9 gives you 21. Okay. And then 2, so it would be 6, 7, 10. Yep, that's right. All right. So here we have lithium sulfate. Okay. What is the symbol for lithium? So we have Li. Okay, I think that shows, yep, that should show up just fine. And then what is sulfate? Is that a monoatomic ion or a polyatomic? And how do you know the difference between a monoatomic and polyatomic ion? So to answer that, would that be correct? It would be if it was sulfide, okay? But as you had correctly had mentioned, this is SO4 because it's a polyatomic ion. Okay. So then notice it's not written out like this was. Do these charges add up to 0? They do not. That is correct. So we start with our negative anion side. What's the charge of sulfate? Negative what? Negative what? 2. Okay, so sulfate is negative 2. Lithium is positive 1. So again, does that add up to 0? What is the least common multiple between 1 and 2? 2. See how much we recall it in case you're wondering, oh my, I remember, and this is yourself talking to yourself, I remember sitting here last, I suppose this would have been in late February, maybe early March. The first time we saw this, and oh my, least common multiple. What do we mean by that? And if it is 2, what's 2 divided by 2?
1.
Okay, and we've got 1 sulfate ion. But what's 2 divided by 1?
2.
So how many lithiums would we need?
2.
And you would need 2 of those. So the answer we get is what we put below. Okay, so we have Li2SO4. So let's go ahead and add those together. If 16 times 3 was 48, 16 times 4 then, you just add 16 to this. We get 64. Then sulfur. I think it's 32 something, right? I think we'll go with that. 0.07, okay. And if you had 32.06, that would be fine as well. And lithium has an atomic mass of what?
6.94.
Okay, so we can do, yep, 6.94. But how many of them do we have? So then we got to take that 6.94 times, okay, so 6.94 times 2 gives us 13.88. 8. So we add those together. That would be 95. Okay. And then let's see here. We've got 9 and 9. Looks like 109.95. We'll double check that. 64 plus 32.07. 109.95. Yep, that is correct. Okay. But of those two so far, these two compounds, if you had to do the dot diagram for those I would say are probably fairly difficult. One of them is actually more difficult than the other. I wouldn't expect you to know that, and maybe general chemistry students wouldn't remember how to do these either. But if we had to do this, we said you would probably want to pick the element in the formula that has the least number of atoms in it, and that would be which one of these three elements. This one's got 2 atoms. This one's got 4. So which one's got the least then? This one's got 2 though, right? How many sulfurs do we have? Just 1. So we'd want to use our sulfur. Okay. So what column is sulfur in?
It's in the 6th column.
So how many valence electrons is that?
6.
Okay. So what we would want to do here, and I wrote that a little too high, or else we're going to run out of space. Okay. So we're going to put this sulfur a little further down, and we're going to put 6. We're going to put 2 there. There's 3, 4, 5, and we'll put the 6th one over here. Okay? Well, where we see lone electrons here, we're probably going to make a bond there. Okay? Be a covalent bond. And this would answer the question if we had lithium sulfide, we'd still have Li2S because sulfide has -2. This is +1. So it would be the same. This would be a lot simpler to do for a dot diagram than what lithium sulfate is. Because where we see these X's, what would you do where you see a lone X? Fill it in with a bond. You'd put a lithium here and a lithium here. But with lithium sulfate, it's really not quite that simple. Okay? So what we mean by that is as follows. Okay? We'll follow a similar pattern. We'd put an oxygen here and an oxygen over here. Okay? So what column is oxygen in? Okay, so how many valence electrons is that? That's still 6 valence electrons, so we use triangles here. They're supposed to look like triangles. Maybe they really don't, but they're supposed to be. Okay, so if you put 6 triangles on this oxygen, logic would say we got to do the same thing here. Okay, so we've taken care of 2 of those oxygens. Well, of all of these elements, which one is the most stable right now? And why, you're correct, why is S the most stable? Okay, it's got 8 electrons around it now. These oxygens only have 7. But what we can do is notice we have 2 remaining oxygens yet. So what that means then is we can put an oxygen up here. If we put one on top, we'll put one on the bottom here. Same concept, oxygens in column 6. 1, 2, 3, 4, 5, and 6. Okay, now the reason that we work on these together is whether it's the first time we have a problem quiz or the exam over this or even on the final, this is how this molecule looks. And it seems like it happens every year, and I don't know whether you could say it's of no fault of our own. Well, maybe, maybe not. Somebody will probably still do this, say, well, we can bond an oxygen on here, okay, because that's got 6. Yes, that's true. And then say, well, we could put a lithium on here because lithium's in column what?
1.
So we could put 1 there. So logic would say we would do the same thing over here. Now, the reason that we say someone will do this, well, we got it right. We got 8 electrons around each one except for lithium. Well, that's true, but that's just not how the molecule looks. That's why we go over that together. So let's go back to how we had it. 1 oxygen above and below. Okay, and then we can put our lithium over here. That is how the compound would actually look. Oxygens around it in all making 90-degree angles, I suppose you could say, and then we've got 180 degrees between our lithiums. All right, so I just thought we'd throw that in there quick on account of, because we got to do dot diagrams too. Okay, so with this cobalt-3 hydroxide, why is there a Roman numeral here? Because you have to ask yourself, where do you find cobalt on the table? And if you're looking, it's somewhere with an atomic number somewhere in the 20s. Is it 20? I forget. It's 24 or 27. I can't. It's further to the right, so it must be 27. Okay. So element 27. What is the symbol for cobalt? Okay. So we have CO. Okay. What is the formula for hydroxide? Notice we said formula. We didn't say symbol. What is because it's a polyatomic ion. What is, okay, so we have OH here. Okay, so what's the charge of this hydroxide? Negative something. -1. Okay. What is the charge of cobalt? It can have multiple charges, but we don't have to guess which one it is. So it has a charge of positive what? Okay? Because that tells us that this is a charge of +3. And again, this is probably going to happen. Some people will choose to do that. Okay? And if you did, cobalt now has a charge of what on this side?
3.
Well, it's got a charge of 3, but then you put 3 of them there. Now you've got 9 positive charges, okay? Because you're taking the number you have times its charge, which we said is +3. That would give us an overall charge of +9, and we know that that's not the case, okay? So here is our charge of +3. What's the least common multiple between 1 and 3?
3.
Okay, so what is 3 divided by 1?
3.
Okay, so the answer we get by that division tells us what to put below. What is 3 divided by 3?
1.
And we got 1 here, just like we had 1 there, just like we had 1 here and here. Okay. Is that correct?
We have to put parentheses in the OH and the 3 outside it.
Yes, that is correct, because Remember, this is one hydroxide ion with a charge of -1, but we want 3 of them. So we have to do that. Now we've got that written correctly. Okay. Front row, are we good so far? Middle row. Back row. Okay, so keep in mind when your final rolls around, we will still print off, I got to change that 18 to a 17. We're still printing off 17 of them. So what you need to think about is you may opt out of it. Some of you may opt out of this, okay? We're not asking for a show of hands right now, okay? Just one of the aspects that you can do, because if we're going to give you a semester exam, we're probably going to grade it too. But some of you do have that option that say, okay, I wasn't very comfortable with this. My grade is high enough and the specifications that I have in this class is enough to opt out. You just write OPT, OUT on top. Then we'll disregard that score. But not everyone can do that. Okay? And does that make sense on who can and can't do this? So, and if you're one of the individuals that, this was maybe a little difficult this year, we're doing what we can to allow us to move in the right direction, because do we have any college-bound students out there? Okay, and that's fine. If the technical schools, whether it's Southeast Technical College, I think is what it is now, and I don't know if it's Lake Area Vocational College or, oh, I said Lake Area by pointing that way. Lake Area is actually up that way. Mitchell Technical College over that way. Okay, so that is about 23 minutes. We try to keep these short because it is a lot of content that we go over all these. So we'll just leave this up here. So then when next Monday rolls around, you say, oh gosh, I could really use some more time on dot diagrams, Bohr models. We'll go over those again. And certainly the reactions, and wrap up with the organic compounds. Anything else that you would like to add? Back row. Anything else we'd like to add?
No.
Okay, rest of the back row. Middle row. Okay, front row. Front row. Is there anything? Okay. Okay, we're nodding. What would we like to add?
No, I'm good. Never mind.
Okay. You're good? Okay. So that puts us up to about 24 minutes. Okay. Okay, so that wraps up our first review session. And again, you have these opportunities to write this down, and then that's what it is. It's an opportunity and it's a choice. Okay? So that's all I have. We'll catch up to you next time.